Hey, let's continue the lecture. So consider this equation. This is the equation we want to solve. Homogeneous equation with constant coefficients. And we already know how to solve it for n equal to 2. We already presented above. Now we can repeat that process for general n. Okay. For general n, we can repeat the same process as above. Namely, look at the characteristic equation. The characteristic equation of this equation here is easy. You can replace the derivative by the corresponding power. So this one is replaced by r to power n, r to n minus 1, and this r, and this one just by 1, right? Then the characteristic equation, just the following equation: an rn plus an minus 1 rn minus 1 plus so on. a1r plus a0 equals 0. So this is a polynomial equation, and in general, hopefully you can solve it. And whenever you solve it, you can find the root. And after you find the root, you can write down this special function y1, yn, and you combine them together. Here's a theory to let us do it. Okay, so a theorem. Right? If the characteristic equation has n distinct real root r1, r2, and rn, then the function y1, which is e to the r1x, y2 e to the r2x, and so on, yn e to the rnx, are linearly independent solution of the equation we need to solve here, equation star. And then a general solution. Is just the linear combination of those. Is y equal to c1 r1x plus so on, c n r to the nx. Okay. The linear combination of y1, y2, and so on. Okay. So let's look at an example. Example 1. We want to solve the equation the third derivative plus 3 times the second derivative minus 10 times the first derivative equals 0. And this equation is homogeneous equation with constant coefficients, because the coefficient is 1, and let's say 3 also a constant, and 10 also a constant, right? Okay. So characteristic equation. So y third derivative becomes r to the power 3, this one r power 2, and this is r, right? So you have r power 3 plus 3 times r squared and minus 10r equals 0. This is a cubic equation, and you see that everything has r. You can take r out, and you have r squared plus 3r minus 10 equals 0. Then you can have either r equal to 0 or r squared plus 3r minus 10 equal to 0. This one is good. And now this is a quadratic equation. You can solve it by using delta notation that I told you in the last lecture. Delta equal to b squared minus 4ac, just 3 squared minus 1 minus 10, which is 9 plus 40 is 49. Okay, and then r1. So this I denote this one by r1, and the two root over for this equation I will call it r2 and r3. So r2 would be equal to negative b plus square root of delta divided by 2a, right? And minus b is minus 3 plus square root of 49 divided by 2 times a, which is 2 times 1, minus 3 plus 7 divided by 2, and it just gives us 2. Okay, that's r2. And r3, which is minus b minus delta divided by 2 times a, which is minus 3 minus square root 49 divided by 2, minus 3 minus 7 divided by 2, and 0. Okay, so we combine all together. Just put them over here. R1 is 0, R2, which is 2, and R3, which is, this is not 2, is minus 5. Okay, minus 5. We have 3 distinct real roots. Then the theorem of both applied, right? And the theorem 1 applies because we have n, that means 3 distinct real roots, right? Okay, so then we would have y1, which is er1x, which is e0x. This is just 1. Y2, which is er2x, e2 times x, and y3, which is r3x, e to the negative 5x. And then the general solution is the linear combination of these 3 functions, right? Okay, so just c1 times 1 plus c2 e2x and c3 e negative 5x. And we can rewrite it a little bit simpler: c1 c2 e2x plus c3 e negative 5x. And this is the general solution of the equation.